Generative AI has been creating inroads into various realities that specialists previously held. The competitors seem to be leveling up the game of racing to the top. Microsoft is making significant strides in the development of AI, and it has come with big news for the curious fellows out there. Recently, there has been a significant advancement in AI research, originating from Microsoft, the PHI-1. Let us have a simple understanding of what PHI-1 is. In this research, Microsoft presents convincing proof demonstrating the enhancing capability of high-quality information in the domain of extensive language models, or ELMs for short. By utilizing ELMs trained specifically for programming, the researchers create customized Python functions from explanations of code. The assessment standard used, called human eval, has been extremely useful in comparing the performance of ELMs for tasks related to coding. The authors explore how improving the quality of data can yield superior outcomes, and it has been found that data cleaning, a critical step in generating contemporary datasets, can lead to more streamlined datasets and the ability to iterate data more extensively. This is an advanced level explanation for those who can understand tech language better. The latest 1.3b parameter model coding LLM, named PHI-1, is reportedly surpassing GPT 3.5 with only 4 days of training. PHI-1 is a novel language model for code with a considerably smaller size than competing models. Microsoft's researchers efficiently trained PHI-1 in only 4 days, utilizing 8 NVIDIA A100 processors. The training involved 6 billion web tokens and 1 billion tokens generated by GPT 3.5, one of the underlying models used to construct OpenAI's ChatGPT. After fine-tuning, PHI-1 successfully completed tasks that were not included in the fine-tuning dataset. This indicates that the model adapted and improved the fine-tuning process. And the most remarkable aspect is that PHI-1 restructured and consolidated the knowledge acquired during pre-training, despite the fact that the knowledge was not explicitly present there initially. In simple terms, PHI-1 not only learns during training, but also expands its knowledge autonomously. Let us understand this in a little more detail and understand how Microsoft achieved this feat. Microsoft Research employed a variety of datasets and methods to create an effective code generation model. This model has reached an advanced level of code generation using a dataset curated by the authors. The researchers found that the majority of current code datasets are insufficient for training models because they do not have comprehensive information or meaningful comments and mostly consist of configuration files or preliminary visions. They carefully selected a trustworthy filter dataset by making use of Python code datasets from the Stack and Stack Overflow. It is a top-notch programming textbook-like dataset developed by authors. By utilizing GPT-4, they evaluated the educational significance of the examples and labeled them appropriately. To determine the quality of each file or sample, a random classifier was trained on the labeled data. GPT-4 was sparring to provide accurate annotations on a portion of the Stack and Stack Overflow examples. This minimized the requirement for time-consuming human annotation with the help of GPT 3.5. They produced a fabricated compilation of textbooks comprising less than 1 billion tokens. These textbooks integrated text that heavily rely on natural language, along with the pertinent code snippets with the aim of enhancing logical thinking abilities and comprehension of algorithms. Constraints were implemented during the generation process to guarantee diversity within the dataset. The methodology demonstrated its efficacy as demonstrated by a specific instance of text that was synthetically generated for the textbooks. Why is it said that it will surpass other models? It surpassed GPT 3.5 on all levels, and it's only a matter of time before smaller models compete with larger ones, such as GPT-4. PHI-1 is a transformer-based model with 1.3 billion parameters, while GitHub Copilot Foundation, known as Codex, has 12 billion parameters. The new language model built on the transformer architecture is basically challenging the notion that increased stack size is essential for improved performance. Microsoft's approach involved improving the quality of training data, which goes against the commonly accepted notion that the bigger the dataset, the better the output. In terms of effectiveness, PHI-1 achieved an impressive human eval passage accuracy of 50.6%. Despite its smaller size, Microsoft's model outperformed Hugging Face and ServiceNow's StarCoder 33.6%, OpenAI's GPT 3.5 47%, and Google's PAL-M 2S 37.6%. According to Microsoft's researchers, the strength of high-quality data is the factor behind the impressive performance of the PHI-1. What is it that makes it stand apart? The new AI PHI-1 can create codes. Have you heard of it? Yes, it can create codes. Wow, so no more programmers also? The Microsoft team proved that PHI-1 can achieve exceptional accuracy scores for tasks related to code, all while being significantly smaller than competing models. In short, it has been defying established scaling rules by achieving impressive accuracy scores on code-related tasks. It excels at complex computational tasks, such as utilizing external libraries, implementing intricate algorithms, and handling natural language inputs. This has the potential to contribute to more efficient and effective language models in the coming years. By offering a new tool to developers and their organizations, we can help shape the future market. Not only does it simplify coding responsibilities, but it also allows technology-focused businesses and developers to boost productivity while reducing resource consumption expenses. This is because PHI-1 can work efficiently using very little computational resources with few datasets. But just like other models, this too is not without errors. So let us look into some of the challenges that PHI-1 is facing with the help of some examples. First, PHI-1 is specifically skilled in Python programming, which limits its flexibility compared to models that support multiple languages. Additionally, PHI-1 does not possess specialized knowledge in certain domains, like programming with specific APIs or utilizing less popular packages that larger models have. Lastly, because of the structured nature of the datasets and the absence of diversity in terms of language and style, PHI-1 is less resilient to variations in style or errors in the prompt. For example, its performance significantly declines when there are grammatical errors in the prompt. In addition to all these, there is another set of ethical issues concerning PHI-1. Okay, well, this is not something new, for we've all been hearing about a lot of these concerns ever since AI became the news of the town. So, what is the ethical issue? The language models themselves will be utilized to curate data for upcoming language models, which further heightens the importance of considering the ethical and societal consequences of training these models. This includes addressing issues of accountability, transparency, and bias related to data and models utilized in this procedure. A few scientists lately suggested that employing information created by a single generative AI or utilizing a single LLM to educate others would ultimately lead to a perplexing outcome later on. Nevertheless, it appears that this is not occurring, at least in the immediate future. It has also been reported that practicing different LLMs information and reality diminishes the excellence of yield of the fresh model as it causes information contamination. This is likewise referred to as the deceptive assurance of duplicating excessive LLMs, as the model likewise acquires imperfection from GPT-based models. And Microsoft is here to suggest measures for the same. Recently, Microsoft researchers have suggested using GPT-4 rather than GPT 3.5 to generate synthetic data for the model's training. This is basically to expand on their work. The remarkable slimness and effectiveness of PHI-1 would have not been achievable without significantly enhancing the excellence of information. It was GPT 3.5 that enhanced and created the top-notch artificial dataset supplied to PHI-1. But don't you think that it's interesting that PHI-1 can achieve such high coding proficiency despite those errors? In this context, let us look into some of the worthy efforts taken by Microsoft in the field of artificial intelligence. Microsoft is leading the way in AI research by providing significant funding. After the announcement that Orca will be open source, another breakthrough in AI, PHI-1, has emerged. During the recent Microsoft Build conference, AI was a major focus, and it was revealed that Copilot will be available on Windows 11. Copilot is a native app that provides comprehensive assistance. AI will also be integrated into Microsoft Teams through the Recap AI tool. Additionally, AI will be utilized in various other Microsoft tools, including Microsoft Fabric. The tech giant recently announced that LongMem is another noteworthy advancement in AI research, as it allows for unlimited context linked. The arrival of PHI-1 by Microsoft Research signifies a notable progression in the realm of language models. Its capacity to utilize top-notch data to accomplish remarkable precision scores on tasks related to code implies a hopeful outlook for more proficient and successful language models. This advancement holds the potential to reshape the market by offering developers and organizations a potent streamlined instrument for coding tasks, lessening ecological expenses and improving productivity. Let me know your thoughts on this new AI model. Where do you believe that AI research is headed? Feel free to share your opinions in the comment section below. For more interesting videos on AI and its latest news, click on the subscribe button and push the notification to get regular updates on the same. So until next time, goodbye.